Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I'm from group 3. Gonna present logarithm. So I'm going to make a little introduction about my teammate. We consist of 6 members, which is IZZATI binti SAHARUDDIN, LIANA binti ARSHAD, WARDAH binti Muhammad ZAINAL, NAJIHAH NORDIN, JAZILAH ZAKI, and GHANI BASRI. So I'm going to make introduction of logarithm. So first, I'm going to remind you that our mindset are very powerful. When we are spirit to do something, even it was hard, we can face it easily. So what is logarithm? Let's make it simple. So logarithm is how many one number. This is basic. The basic of logarithm. Logarithm is how many of one number do we multiply to get another number, which is for the example, how many 2 do we to multiply to get an 8. So if we gonna use basic calculation, we going to multiply 2, multiply by 2, multiply other 2, so we got an 8. So we need 3 of number 2 to get an 8. So the logarithm is 3. So basic calculation for involving logarithm is for common logarithm. For log xy, we can convert it to log x plus log y, and log x over y, we can convert it to log x minus log y, and so on. Then we're going to have application log to pH problem, which is pH equal to negative log dalam kurungan hydrogen ion concentration equal to negative log H plus. So this is basic of calculation formula of log, which is pH equal to negative log H3O plus, POH equals to negative log OH minus, or pKa equal to negative log Ka, pKb or equal to negative log pKb. So for the remainder, log 0 equals to error, log negative number also equals to error. So we're going to have a little example for find pH, which is pH equal to H3O plus equal to 2.8 times 10 negative 4 m. So pH equals to negative log H3O plus, so we can convert the number pH equals to negative log 2.8 times 10 negative 4. So we can get pH, which is 3.55. Alright, thank you.
Bismillahirrahmanirrahim. So the question given is, calculate the mass of calcium hydroxide needed to produce 250 ml aqueous solution with pH 10.65. Okay, first and foremost, we need to write the chemical reaction of calcium hydroxide. Then we can use the formula pH equal to 14 minus POH. Okay, since we already have the pH, which is 10.65, we can substitute it into the equation, and we can get the value of POH is 3.35. Next, to calculate the concentration of OH minus, we can use the formula POH equal to negative log OH minus. So we can substitute the 3.35 into the formula to get the concentration of OH minus, which is 4.467 times 10 power of negative 4. Okay, we need to divide 4.467 times 10 power of negative 4 with 2 because if you refer to the equation that we have wrote before, it is stated that it is 2OH minus. So that's why we need to divide it by 2. Okay. Next, we can get the concentration of OH minus is 2.234 times 10 power of negative 4. Okay. Next, to get the mole of the solution, we need to use the formula mole over volume equal to molarity. Okay. We already get the concentration, also known as molarity, which is 2.234 times 10 power of negative 4. Then we can substitute it into the formula. And we also already have the volume, which is 250 milliliter. But we need to convert it into the liter first. So it will be 0.25 liter. So we can get the mole by 2.234 times 10 power of negative 4 times 0.25. Then we can get the mole, which is 5.585 times 10 power of negative 5. Okay. Next, the last step is we can use the formula mass equal to mole times molar mass, which is molecular mass. Okay. Then we can substitute 5.585 times 10 power of negative 5 as the mole and 74.1 as molecular mass of calcium hydroxide. Then we can get the final answer, which is the mass of the solution with pH 10.65 equal to 4.14 times 10 power of negative 3 gram.
Bismillahirrahmanirrahim. And we start this topic, logarithm with application of acid and base. Application introduction. The hydrogen ion H plus concentration or H plus in a solution is measured using pH scale method. The pH is defined as the negative logarithm of the hydrogen ion of H plus or H3O plus concentration. And the formula is pH equal to negative log concentration H plus or pH equal to negative log concentration H3O plus. The higher the concentration of H plus or H3O plus, the lower is the pH value. And we know when lower the pH value, we call it basic solution or alkali. In similar way, POH is the negative logarithm of the hydroxide concentration. The formula is POH equal to negative log concentration OH negative. The higher the concentration of OH negative, the higher the pH value. And we also know when the pH is higher, it is a acidic solution. Okay, example question. What is the concentration of natrium hydroxide solution with pH 10.5? Okay, the question want us to find the concentration of NaOH, and by given the pH 10.5, right? Here is the way to solve the question. The pH is 10.5 and we must use the formula POH, and then we must find the POH equal to 14 minus 10.5, and we get it 3.5. From 3.5, we can just substitute in the formula, which is POH equal to 3.5 equal to negative log concentration OH negative. And then we just use the calculator to find the last answer, which is antilog negative 3.5, and we can get the concentration of NaOH, which is 3.16 exponent 10 exponent -4 molar.
So, Bismillahirrahmanirrahim. We will continue to the application log in Arrhenius equation. Okay, so, what is the function of Arrhenius equation? It is used to show the effect of a change of temperature on the rate constant. So, this is basically the Arrhenius equation, which is K equals to A E to the power of negative EA over RT. Okay. So what is K? K is the rate constant, and we usually use as -1 as the unit. Okay, so A is the frequency factor. E is the base of the logarithm scale. Okay, so what is the EA? EA or E sub A, we call it activation energy, and the unit we use in activation energy is kilojoule mole -1. Okay, what is T? T is the absolute temperature. We use Kelvin as the unit. So if there is degree Celsius, so we must convert it into Kelvin. Okay, and lastly R. R is the gas constant, which is 8.314 joule K -1 mole -1.
Arrhenius equation also can be expressed in a more useful form by taking the natural logarithm of both sides. There is two useful form, which is first, ln k equals to ln a e to the power of negative ea over rt, or one is ln k equals ln a negative ea over rt. At two different temperatures, where A is constant, Arrhenius equation can be written as ln K1 over K2 equals to A activation energy over R, and in the bracket is 1 over T2 minus 1 over T1. This equation also take the form of a linear equation. This equation always used in for graph. And the equation is ln K equals to negative activation energy over R times 1 over T plus ln A. And this is the form of linear equation, general linear equation, which is y equals to mx plus c.
So we move to the example questions of Arrhenius equation. Okay, question 1. Rate constant K1 and K2 for the decomposition of gases the nitrogen peroxide are 3.7 times 10 to the power of -5 as -1 at 25 degrees Celsius and 1.7 times 10 to the power of -3 as -1 at 5 degrees Celsius respectively. What is the activation energy in kJ mole -1 of this reaction? Okay, firstly, we look at the quick tips. Okay, so we have all of the information, which is we have K2, K1, K2, T1, T2, and also R. So R, we just use the constant, which is 8.314. Okay, so in this question, we can extract the K1 and K2, which is we assume the K1 is equation 1.7 times 10 to the power of -3. So the T1 is 5 degrees Celsius and K2 is 3.7 times 10 to the power of -5. So the T2 is 25 degrees Celsius. Okay, because it stated that it is respectively, so you guys can can assume either 1.7 times 10⁻³ as K1 and 3.7, the 3.7 is the K2, or you can also assume 3.7 as K1 and 1.7 is K2. Okay, but should be careful of when you assume it as K1. So the temperature will be T1. So when you assume the K2, so the temperature is the T2. So what is the elevation? Okay. So we have all of the information. So we substitute it in the formula of ln K2 over K1 equal to EA over R bracket 1 over T1 minus 1 over T2 close bracket. Okay. So the second step, we must convert unit the degrees Celsius to Kelvin. So the value, for example, 25. So 25 plus 273.15 to get 298.15. And also 5, we add it with 273.15, so we get 278.15. Okay. So we substitute like in the slide. So um, so the right hand side, which is the bracket, the 1 per T1 minus 1 over T2 in the bracket, we move it to the left hand side. So we divide ln with the temperature and the answer of the division, we times it with 8.314. So we get activation energy as negative 131,948.73 joule per mole or J mole negative 1. Okay, so why we have this J mole negative 1 as a formula? So we already cancel out all of the unit, which is S and K. We have S, K, J and more, right? So we already cancel the K and S. So the remaining unit is J more negative 1. Okay, so but the question asks in Kj more negative 1. So we must convert from the J to Kj more negative 1. So we simply times it with 1000, or we simply move the decimal places. So we got negative 131.949 kg more negative 1.
Example question. Consider the reaction to NO2 gas to 2NO gas plus oxygen gas. When the temperature is 300 K, the rate constant is 1 times 10 to the power of negative 10. And the activation energy is 111 kilojoule mole negative 1. What is the temperature when K is equals to 1 times 10 to the power of negative 11? Firstly, we need to label which one is T1, K1, T2, K2, and the activation energy given is in kilojoule. We need to convert it first into joule and multiply it with 1000, and it gives 111,000 joule mole negative 1. From this question, we need to use the equation that have two different temperature, which is ln K1 over K2 equals activation energy over R, and in the bracket is 1 over T2 minus 1 over T1. For your information, the R is molar of gaseous constant, which is 8.314 joule K negative 1 mole negative 1. Then you need to substitute the formula with the information given. Then you will have 1.7247 times 10 to the power of negative 4 equals to 1 over T2 minus 1 over 300. Minus 1 over 300 need to move, and you will get 3.5058 times 10 to the power of negative 3. So you need to determine the T2, and the answer is to add 5.24K.
Assalamualaikum warahmatullahi wabarakatuh. My name is JAZILAH binti ZAKI. I will explain about application of logarithm in first order direction for integrated rate law. So before we proceed with first order direction, let's have a quick brief about integrated rate law. So it is to determine the amount of reactant or product present after a period of time, or to estimate the time required for a reaction to proceed to a certain extent. So for example, integrated rate law is to determine the length of time a radioactive material must be stored for its radioactivity to decay to a safe level. Okay, so what is the first order reaction? It is an equation relating the rate constant K to the initial concentration A0 and the concentration AT present after any given time can be derived for a first order reaction and shown to be like this equation. So ln AT over A0 equal to negative KT, or we can also write it as ln A0 over AT equal to KT if you have a positive constant value. So from this equation, we will have we can also rearrange it into standard linear equation format, which is ymx plus p, where we rearrange it into ln A equal to negative k times t plus ln A0. So the half-life of first order reaction. So half-life is the time required for 1/2 of a given amount of reactant to be consumed. So we can derive an equation from the integrated rate law that we have earlier. Ln A0 over A equal to KT. So we want to find T. So we rearrange it into T equal to ln A0 over A times 1 over K. So if we set the time T equal to the half-life, the corresponding concentration of A at this time is equal to 1/2 of its initial concentration. Hence, when T equal to T half, the concentration A equal to half A0. So we insert into this equation T half equal to ln A0 over half A0 times 1 over K. So this ln A0 over half A0, we will get ln 2 times 1 over K. So the final answer for half-life is 0.963 over K. So the example question for this first order reaction, the conversion of cyclopropane to propene is a first order reaction with a rate constant of 6.7 times 10 to the power of negative 4 per second at 500 degrees Celsius. So if the initial concentration of cyclopropane is 0.05 molar, what is the concentration of cyclopropane after 30 minutes? So we use the formula that we have earlier, ln AT equal to negative KT plus ln A0. So A that we have is cyclopropane C3H6. K that we have is constant value that we have is 6.7 times 10 to the power negative 4, and T we convert it into second, 30 minutes into second, and we get 1800 second plus ln A0, which is 0.05 molar. So how we want to get rid of the ln, because we want to get the concentration only. So we add E exponential into both sides, because ln is log base E. So if we put E in front of the ln, it will cross over the ln like this. So you can just calculate in a calculator E to the power of all of this, and we will get the concentration of cyclopropane is 0.015 molar. So So next, how long does it take for the concentration of cyclopropane to reach 0.001 molar? So this question it want the time and give us the concentration. So we put inside the same formula. A we change it into 0.01 molar equal to constant value times T. So we want to find T plus ln A naught. So rearrange it into T equal to ln 0.01 minus ln 0.05 over a constant value 6.7 times 10 to the power of negative 4. So you will get 2402 seconds, or convert into minute, approximately 40 minutes. So last equation is what is the half-life. So from the derivation we do earlier, half-life is equal to 0.693 over k. So k we just inside the constant value from the equation, which is 6.7 times 10 to the power of negative 4 per second, and we will get 1034 seconds, or approximately 17 minutes. So that's all from us. Thank you.